Final question in the 2019 exam was looking at the application of sine rule, cosine rule and various other trig functions to real life applications. Now this one had Katie and Mona going up in a hot air balloon. This diagram here represented the positions of Katie, Mona and the balloon respectively. Angle of elevation from Katie is 52 degrees, so there's Katie. Angle of elevation from Mona is 34 degrees. They're both 350 metres apart on level ground. We want to calculate the height of the hot air balloon above the ground. So we want that there. We want the height. Now we know the height from the balloon to the ground is perpendicular to the ground. If we look at that, we can then sort of split it off into a pair of right-angled triangles. Now we've got angles and sides in the right-angled triangles, which would tell us that we can use SOHCAHTOA. We can use trigonometry in there. But in order to use trigonometry, we need to know a side in the triangle. So if I wanted to split it off into this side here on the left with Katie, if I wanted the height, I would either need to know this side on the bottom or the hypotenuse. If I was looking at the right-hand triangle with Mona, I'd again need either the base or the hypotenuse. Now we know the total length along the base. The only thing we don't know is the ratio in which it's split. So how much of this side is from the base and how much of this side is from the base. What we then need to look at doing is calculating the hypotenuse of each of these two triangles and then working it out from there. Now, it doesn't matter which triangle you split it into. I could split it into Mona's one, I could split it into Katie's one. The bottom line is you should get the same answer for your height in each one. And I want to show that to you by splitting it up into both. So the first thing I need to do is calculate one of these sides. So I've got angles and I've got sides opposite them, so what I want to use is the sine rule. Now we need to fill in the third angle here because that's opposite a side that we already know. But we know all the angles in a triangle add up to 180, so what I can do is say fine, so this angle here is 180, take away 52, take away the 34 degrees that's there, so what that means is this angle here is 94 degrees. So now I can use all this information, split it up into the triangle I want, and then take it from there. So let's imagine I'm going to show you Katie's triangle first. So let's say I wanted to split it off that way, and this is the triangle I'm looking to get. I need to get this side here. Well, I know that that side is opposite that angle, and this side is opposite this angle. So what I can do is I can set up the sine rule to find this missing side here, KB, so let's call this missing side here X, and then use that as the hypotenuse of a right angled triangle to find H. So what I can then say is fine, so X over sine 34 equals the ratio of these two sides, so it equals 350 over sine 94. Now that I've got this, I can shift the sine 34 up and I can solve it to find X. So I then know that X is equal to 350 times sine 34 all divided by sine 94. So I know that X represents the side KB, so from that I can safely say that KB is equal to this, plug it all into a calculator, and I get 196.195, and then it continues on, so round it to 196.2. So now that I have that side, I can essentially sketch the triangle there. I know that there's my corner K, there's my corner B, this side here is H, my height. I know that this side here is what I just calculated, which is the X. I have a value for that, and I know the angle that's here, that's 52 degrees. So I can then use SOHCAHTOA to get the height across here. So remember, for SOHCAHTOA, sine is opposite over hypotenuse. So I can then say safely that sine of 52 is equal to the opposite, which is the height, divided by the hypotenuse, which I've just calculated down here, is 196.2. Rearrange this and jig it about. What I can then say is find my height then is 196.2 times sine of 52. Plug it into a calculator yet again, and I get 154.6 meters, rounding it to one decimal place. So using this triangle and splitting it off this way, I get a height of 154.6. Now, if I was to split it off and use this side, so use Mona's side, I should still get the exact same height at the very end of the calculation. So let's see if I do that. So there's Mona's triangle. And again, I'm going to start with the exact same way, using the sine rule. The only difference is because I want this side here, so for this calculation I'm going to call it y, I want to use the ratio of this side and angle. So for Mona, the only difference is that I'd start by saying that y over sine 52 is equal to 350 over sine 94. Now, none of the general steps changes, just that little numerical value here. So I still solve it by switching it around as I did here for the x. So I'd say fine, so I know then that y is equal to 350 times sine of 52, all divided by sine of 96. Plug it all in a calculator again, just as I did before. What I get then is that y, which is equal to bm, is equal to 276.477, and then it continues on, so it's 276.5. Don't forget your units. In this case, it's meters. So my side BM, this one here, is 276.5 meters. I can now construct my triangle on this side and see what I need. So if I do my triangle there, I know it's a right angle in here. This corner down here is M. This corner up here is B. This is my height that I'm after calculating, and this side here is what I've just calculated in terms of y. I also know this angle down here. This is the 34 degrees from the original diagram. So again, I can use sine from the SOHCAHTOA to calculate the height. I know then sine 34 is equal to h over the value I just calculated there, 276.5. Rearrange it, and what I end up getting is that h is equal to 276.5 times sine 34. Plug that in a calculator, and lo and behold, what we get is that h is equal to 154.6 meters. So we get the exact same answer. It doesn't matter which of the two ways you split it and which of the two triangles you look at, as long as you do the working right, you should still get the same answer each way. Follow the one that looks best for you. So if you prefer the smaller numbers and smaller angles of one side, stick with that. Doesn't matter which way around you split it. Bear that in mind. There's a lot of questions that are like this. There's a lot of questions where there's more than one set of steps or one set of numbers you can use to solve the problem. You just have to make sure you use the one which you're most comfortable with and which you can follow through the best.